of alcohol. And we know that alcohol has our CH2. This will be further bonded with oxygen and then further bonded with hydrogen. So there are two bonds which could be taking part in the chemical reaction. Okay. So here we have this bond, that is carbon and oxygen bond. If it breaks, there will be a few reaction, and if oxygen hydrogen bond break, there will be another kind of reaction. So this is the cleavage of CO bond, and when the OH bond breaks, you see that it is a cleavage of OH bond. Okay, so we were discussing this type of chemical reactions. Now, please write the second chemical reaction which can happen. Please write the second one. First one was the acidic nature, and the second one is reaction with carboxylic acid. Reaction with carboxylic acid. Carboxylic acid. So we will take any carboxylic acid. Let us suppose we have R dash, any alkyl group with carbon double bond O. Just a second, guys. Now carbon double bond O and then OH. Okay. Plus we have alcohol. I'm writing alcohol like this. You have H, O, and then the R group of alcohol. When both of these react in the presence of HCl, okay, in the presence of HCl, or you can also have concentrated H2SO4, then they actually liberate water like this. OH is from the carboxylic acid, and H is taken from the alcohol. So when you remove this part, you will get R dash, C double bond O, and this carbon will be directly bonded to this oxygen atom and further to this particular R group that is from alcohol. Now, important point to note down here is that this particular section, this is coming from the carboxylic acid, and this OR, this is coming from the alcohol. Okay, so this is coming from the alcohol. This is from carboxylic acid. And this OR section, it is coming from alcohol. All of you understood this? Yes or no? Please tell me. Let us see, for example, if I have CH3. Yeah, tell me.
Sir, then what about the OH and the H atom?
That will be liberated as water.
Plus H2, okay.
Okay, H2. No.
Yeah.
So generally, I don't write the byproducts because in organic chemistry, these products, which are the organic product, these are more important. And these are, I would say, these are the only important products that we are getting. Yeah? So many of the times you will see that I'm ignoring the byproducts. So those byproducts are not important. Wherever the byproduct is important, there are a few cases in which they are important. And then at that time, I generally mention that this is the byproduct and it is also important. Okay.
Okay.
Okay. We have CH3 and we have C double bond O, and we have OH. This is the carboxylic acid, and then we have CH3 OH, that is the alcohol. In the presence of, you can have H2SO4. In the presence of H2SO4, what is going to happen? This CH3 C double bond O will be as it is. CH3 C double bond O will be as it is. Now this carbon atom will be joined by oxygen, which is further joined by the alkyl group of alcohol, CH3. Okay, so you need to first of all keep the carboxylic acid as it is, the C double bond O part, and then add O and whatever alkyl group is present in the alcohol. So let us suppose if you have 1, 2, 3 carbon atoms, and then you have C double bond OH, So sometimes you will see just this, okay, COOH. So you have to understand this is carboxylic acid, plus I am having 2 carbon atoms and OH. So in the presence of HCl, so here 1, 2, 3 carbon atoms. So 1, 2, and 3 carbon atoms. This carbon atom will have a double bond O. That double bond O is as it is, bonded with oxygen, and then we have the 2 carbon atoms here. So 1 carbon atom here and the other carbon atom here. Okay, this is one way of writing it. Otherwise, you can also write 1, 2, and 3 carbon atom, CO as it is, and then you can further bond it with O, CH2, CH3. Now, if you feel like it. But I would say the better way is this one only, because from here you can easily identify that this part it is coming from what? This part it is coming from the alcohol, and this portion, this is coming from the carboxylic acid, and also this double bond. All of you got this? Yes or no? Please tell me.
Yes, sir.
Okay, now let us see how to name this type of molecule when we have esters. So as soon as you see this portion, C double bond O and single bonded O, that means the functional group is O8. Those who have done a bit of nomenclature with me, they can understand this method. I teach this method that is known as SPUF, in which you identify the functional group, then you identify any unsaturation. So you will see whether there is double bond, carbon-carbon double bond, or if there is no carbon-carbon double bond. Right? So you will see if there is carbon-carbon double bond or triple bond. If both of these are not present, then you will write AN. If double bond was there, then I would have written EN. If triple bond was there, I would have written YN for the unsaturation. Now, after that, I will choose the parent chain. Now, this is a bit different from what you must have done previously. Most of the people, they start with the parent chain, but parent chain essentially should come in the third position to identify the functional group, because parent carbon chain should contain the functional group. And that is why this carbon atom, it is the functional group carbon atom, which is containing C double bond O and oxygen. So this is the parent. This carbon atom should be in the parent. So you'll have 1 carbon, 2 carbon, and 3 carbon atom, which is going to write 3 carbon atom will be prop. So I will write prop here. And then I will look for a substituent. So what is substituent? After the identification of puff, whatever remains is a such substituent. So as you can see, we have already identified the functional group, that is this oxygen, and these 3 carbon atoms. So we have identified all of these. The only remaining portion here is this 2 carbon atoms chain. So this alkyl group chain, which is 2 carbon atom, for 2 carbon atom, we write eth. And because it is a substituent, we write YL, ethyl or ethyl. Now the time comes to number these things. So obviously O8 will be in the first position. So you don't try to write 1 if it is in 1. So the name is going to be ethyl. Also, I don't need to number ethyl because ethyl is not on the parent chain. It is attached with oxygen atom. Okay, so ethyl propanoate. So as soon as I have written, see, ethyl propanoate as it is. Huh? No dikkat. So as soon as, yeah, tell me.
Sorry to interrupt, but since the unsaturation, we have a double bond, right? Why is it N?
No. Carbon double bond. Said no?
Oh, okay.
Carbon. Okay.
Right. Okay.
Okay. And as soon as I say O8, each and everyone who is reading this particular name, as it ends with O8, there should be a substituent. And this substituent, if it is not numbered, it is on what? It is on the oxygen atom. If it is not numbered. Okay, so ethyl, it is not numbered. It suggests that it is on the oxygen of the ester. Okay, so this is what? This is an ester. All of these are what? Esters. All of you done writing? Yes or no? Please tell me. Aliza, Fia, Deborah. Anyone still writing? No one's like. Fine. Majid, you are able to understand?
Yes, sir.
Okay. Right, next. Okay, write the statement here. Alcohols react with. Yeah, all these are esters only. Okay, so please write alcohols react with carboxylic acid in presence of concentrated H2SO4 or dry HCl to form ester. After that, write some remarks. Okay, the remarks, write the first point. The above reaction is called esterification. Right, next. The presence of bulky group on either alcohol or carboxylic acid, Ca is carboxylic acid, reduces the rate of esterification. Reduces the rate of esterification. Now, what does that mean? It means that for alcohol, rate of esterification, it is going to be CH3OH, which is not having any bulky group. This will be fastest, followed by 1 degree, followed by 2 degree, and then followed by 3 degree. Similarly, for carboxylic acid, rate of esterification CH3OH will be most, followed by 1 degree, followed by 2 degree, and then followed by 3 degree. Oh, my bad. Wait a second. CH3OH near. For carboxylic acid, it is going to be HCHO. HCOOH. My bad. Write this down. Let me know once you're done. Okay. Anyone still writing?
Yes, Soham sir. Done, sir.
So this is known as esterification reaction. Also, this type of reaction is also shown by phenols. Okay, this is also shown by phenols. Please write the third point in the remark. Phenol shows Phenol shows similar reaction. Okay. So if I have, let us suppose phenol something like this. OH in the carbon atom, plus I will have CH3, C double bond O, and OH. The presence of HCl, what we are going to get? See, this CH3 and C double bond O will be acetous, will have oxygen atom, and this oxygen will be further bonded with phenol. Further bonded with, sorry, not phenol, rather it is going to be the benzene ring or the phenyl group. So it is known as phenyl. Why phenyl? Because phenyl is added to the oxygen atom as a substituent. Okay, so phenyl ethanoate. Two carbon atoms, so ethanoate. Or we also call this phenyl acetate. So CH3, C double bond O and O. This portion, it is known as acetate. Okay. We will see what is acid mean in the next chapter, aldehyde ketone carboxylic acid. ये तो एक बार आ गया बस. This is just here for once. You will not see this many times. Okay, acid. All right, next. Reaction with acid chloride. I think I'm using red. So this is the third reaction. Reaction with acid chloride and acid anhydride. Acid chloride and acid anhydride. Okay. Now, in this reaction also, it's very similar to the previous one. We have CH3, C double bond O, chlorine, plus we have H, oxygen, and then CH3, let us suppose. This is my alcohol. So here also what happens? This portion is hydrogen and chlorine. This is taken out, and we have CH3, C double bond O as it is, further bonded to OCH3, OCH3. Okay, this is something that we get, plus we are going to get HCl. Okay. In the next reaction, we have acid. This is acid chloride. Okay, this is acid chloride. So, and if I have acid anhydride, so acid anhydride has a structure CH3, carbon, double bond. Anhydride means here we are going to have oxygen, but not the hydrogen. No? It was acid. So when it was acid, it was OH, but we don't have hydrogen. So what do we have? We have again acid. So what is acid? Again, the same thing. Carbon double bonded with oxygen, further bonded with CH3. This is acid anhydride. If you react this with CH3OH, so please see what happens actually. Erase this part. Okay, and we are having a reaction like this. Both of these are reacting. So carbon gets a bond with oxygen atom like this, and this oxygen, it gets a bond with hydrogen atom like this. And the product that we are going to get is CH3, C double bond O, CH3, C double bond O, and this carbon is now bonded with OCH3. OCH3. Okay, plus, please see. Now you have this CH3 and this C double bond. CH3 and this C double bond O. Now this C double bond is further connected with oxygen. So this is connected with oxygen. And this oxygen is now connected with hydrogen. So we'll write OH. Okay, so here also we are getting what? Here we are also getting ester, and here also we are getting ester. And in both the cases, I'm getting here carboxylic acid, here I'm getting hydrochloric acid. So the byproduct is acid. That is why we use a base, that is pyridine, as a reagent. Pyridine neutralizes HCl, and if the amount of product is decreased, the reactions shift in the forward direction to increase the amount of product according to the Lee-Chatelier principle. Le-Chatelain principle was in equilibrium. Pyridine. Pyridine is a base which neutralizes the acid formed in the reaction. All of you got this? Yes or no? Please tell me. Anji, बताएं. All of you got this? The reaction, what is happening? Oh my God. किसी को समझ नहीं आया क्या हो रहा है? Aliza, Deborah, Fadil, Fia, Hussain,
Sir,
Majid.
can you explain it again?
No problem. So in the first reaction, you can see what is happening, yes or no?
No, sir, the second one.
Second one, see. I will tell you with regards to the electron rich and electron poor. Okay, so we'll identify electron rich and electron poor. This carbon atom, it is bonded with double bond oxygen atom. Okay, so this carbon is bonded with more electronegatives. That is why it will be delta positive. Okay, now this oxygen atom, you must know that it has 2 lone pair electrons. Okay, so this oxygen atom will attack here. Okay, and since it is attacking there, this oxygen atom, which is having a lone pair electron, this will come near the hydrogen atom, which is having delta positive, because this hydrogen is bonded to what? This hydrogen is bonded to oxygen atom, and then this oxygen will attack on the hydrogen atom. As soon as this oxygen, the alcohol oxygen attacks on the carbonyl carbon, this bond breaks, and as soon as this oxygen atom attacks on the hydrogen atom, this bond breaks. Now, can you understand? Yes or no? Please tell me, Aliza.
Yes, sir.
Okay, fine. Write some remarks here. What about others? Majid and Hussain, Fadil, you guys tell me. Understood? Yes or no? Fadil, Hussain,
Yes, sir.
Majid.
Yes, sir.
Yes, sir.
I'm asking especially of all of you guys because you did not attend the backup classes of haloalkane. So in haloalkane, all of these students, they have attended at least I would say how much? At least 10 more classes than you guys. And more than 10 because we also did 11th class organic chemistry, the basics, the general organic chemistry. Okay, so they would obviously understand a bit more. So you guys, please tell me if you don't understand something. Okay? Now write remarks. The remarks are the first point. This reaction is AKA. AKA means also known as acetylation. Also known as acetylation. Acetylation reaction. As the reaction introduces. As the reaction introduces this group, it is known as acyl group. So it introduces acyl group. Acyl group, that is CH3 C double bond O. Okay, this is acyl group. Acyl group in alcohol. Right, next point. Pyridine is used. Pyridine is used to neutralize the acid form. To neutralize the acid form during reaction. The acid form during reaction, and it leads to rightward shift in equilibrium. According to Le-Chatelier's principle. Le-Chatelier's principle. And the third point, phenols show similar reaction. This is also phenol, hai na? This is also phenol plus. I will take acid anhydride. What is acid anhydride? CH3 bonded to CO, that means C double bond O. And this carbon will be bonded to oxygen, and this will be twice. This is also a short form of acid anhydride in the presence of H plus. Rather not H plus, don't write anything here. You are going to get oxygen doubly bonded with carbon atom and then CH3. Is everyone done? Yes or no? Please tell me. Anji, everyone done? Anyone still writing? Okay, if you're not writing, then let us look at the B part. B part means we have seen all the reactions that are involving the breaking of OH bond. Now let us see reactions involving the cleavage of CO bond, and rather it is COH bond. Huh? COH bond. All of you done? Yes or no? Please tell me. Okay. Now let us start reaction involving cleavage of OH bond. Please see, breaking of bond will be easier if these bonds are already very polar. If this bond is very polar, that means it is having a high delta positive charge and it is having a high delta negative charge. So breaking of this will be very easy, so that we can have pure positive and pure negative charges. So once we have pure positive and negative charges, there is no bond here. So first of all, you will write higher the polarity of COH bond, easier it is to break the bond. Right, next. As the number of alkyl group increases, at alpha carbon, the electron density around oxygen atom increases, making the bond more polar, and easier to break. Okay, so therefore, if I talk about the reactivity of different alcohols, 3 degree will have the most number of carbon atom attached at alpha, so it will be most reactive, followed by 2 degree and followed by 1 degree, and the least reactive here will be CH3OH. It will be CH3OH. Okay, so let me show you what actually happens in the 3 degree carbon. We have carbon atom that is bonded with OH, and this carbon atom, it is bonded with some other alkyl groups, R group, and R group. So all of these are giving electron density towards the carbon atom, and this is further giving electron density to the oxygen atom. As you can see, we have a lot of giving of electron towards oxygen atom. It is Okay, one thing I am just expecting you guys, I am expecting from you guys that you know that plus I group and minus I group. All of you have heard about plus I and minus I. Tell me guys, yes or no? Hussain, Fadil, Majid, Aliza. Hussain, tell me, you have heard about plus I, minus I? Fia को तो पता होगा, Fia आपको पढ़ाया है. बाकी लोग, Majid, Hussain and Fadil, especially you guys. Yes, Majid. Oh, Majid, you are not in class or what? Majid, am I audible? Hussain and Fadil.
Yes, sir.
You have heard about plus I and minus I?
So
Yes. What about Majid?
Yes, sir.
Okay. What about Hussain? Hussain, have you heard about plus I and minus I?
No, sir.
No. Okay. No problem. So plus I means electron donating group. Okay. So they give electrons away from themselves. And generally, do you know about this word electronegativity? Hussain? Electronegativity.
Yes,
Generally,
sir.
they have less electronegativity to plus I group. And minus I group, they attract electron towards it. These are electron withdrawing groups. Okay. So the alkyl groups, these are generally having less electronegativity. That is why they give electrons. And on oxygen atom, it is having more electronegativity. That is why it is attracting all the electrons. Fine. Now you understood? Yes or no? Tell me. Plus I and minus I.
Yes, sir.
Okay. So all the alkyl group, these are giving electrons toward oxygen atom, making the oxygen atom a highly delta negative. And higher the delta negative here, higher will be delta positive. So this bond becomes very polar in 3 degree. Then as we reduce the number of R groups, it will become a bit less polar. If you remove even more, it will become a bit even less polar. If you remove one more R, it is going to become least polar molecule. All of you got this? Yes or no? Please tell me why the
Yes, sir.
reactivity is highest in 3 degree, 2 degree, and then 1 degree, and then at last CH3. Now, right here, first of all, the reaction with hydrogen halide. Reaction with hydrogen halide. Now, please write alcohols react with hydrogen halide to form corresponding haloalkane. To form corresponding haloalkane. Okay. Please see. Now, if I have ROH and I react with hydrogen means hydrogen, halide means halogen is represented by X. Okay. So X can be fluorine, chlorine, bromine, anything. Then I will get obviously Rx plus H2O. Now, if I talk about the reactivity of different halogens, we see. If I talk about the reactivity, so in terms of HX, if I talk about HX, then it will depend on the size of the halogen atom. It will depend on what? It will depend on the size of halogen atom, because larger the size of halogen atom, weaker will be the bond. That is why hydrogen iodide will be fastest in reaction, followed by HBr and followed by HCl. HF is so less reactive, it is so less reactive that it does not even show the reaction. Okay, it becomes very unreactive. If I talk about the alcohol, then in terms of alcohol, our reactivity order will be same. 3 degree most reactive, followed by 2 degree and followed by 1 degree. All of you got this? Yes or no? Please tell me.
Yes, sir.
Now, after this, write remarks. Now, in remarks, write the first point. due to lower reactivity of HCl with 1 degree and 2 degree alcohol. See, HCl is also very less reactive. HCl is very less reactive. 1 degree, 2 degree are also very less reactive. Huh? So due to the lower reactivity of HCl with 1 degree and 2 degree alcohol, we use anhydrous ZnCl2 as catalyst. Anhydrous ZnCl2 as catalyst. Okay. Now, that's the second point. So now we have what? HCl. We use HCl, and we also use what? Anhydrous zinc chloride. And this whole thing together, it is known as Lucas reagent. Now I will represent Lucas reagent by LR. In the examination, please don't write LR, okay? It is just for my denotion. LR means Lucas reagent in my class, okay? LR. Right, next. Third, LR, that means Lucas reagent, is used for distinction between 1 degree, 2 degree, and 3 degree alcohol. So basically, if you react any alcohol, with Lucas reagent, with what? Lucas reagent. What is Lucas reagent? HCl and anhydrous ZnCl2. Then you will get alkyl chloride and water. Now this alkyl chloride, it is white, PPT. Okay. And in the presence of water, it shows turbidity. That means basically, if you have alcohol, and you add Lucas reagent in the lab, you will see turbidity in the test tube or the container. All of you got this, yes or no? By the way, do you understand what is turbidity, yes or no? Anji, all of you understand what is turbidity? No one understands what is turbidity. Any idea about turbidity? किसी को नहीं idea? Just a second, let me show you what is turbidity. Basically, if you have chalk and water, na, and if you mix chalk and water, okay, strength नहीं होता, no, strength नहीं होता. If you mix chalk and water, उसको turbidity बोलते हैं ना, उस type के solution को turbid solution बोलते हैं. I can't get any turbidity. Why I can't get turbidity? Maybe I can use this image. So this type of solution, now, this type of solution will be formed only if you have what? White PPT, right? So this is known as turbidity. All of you got this? Yes or no? Tell me. Understood now? Aliza, Deborah, Fadil, Pia, Hussain, and Majid. हाँ जी बताएं. अरे yes or no तो बोल सकते हैं आप लोग. इतना ज़्यादा शर्माना है.
Yes, sir.
Thank you very much. हाँ जी. Yes or no तो बोल सकते हैं आप लोग. चलिए. ठीक है. That is turbidity. Now, how it is distinguishing 1 degree, 2 degree, and 3 degree? Let us understand that. Now, the distinction between 1 degree, 2 degree, and 3 degree. No, not in the change. Turbidity means white जो colorish आ गया ना, that is turbidity actually. Okay. So that you see that it is not dissolved. Something is not dissolved. Okay. Now, please see the difference. The distinction is done by the order. 3 degree is fastest, 2 degree is slow, and then 1 degree is least reactive. That is why, please see, if I have 1 degree alcohol, plus Lucas reagent. Then it shows turbidity on heating. If you don't heat it, it will not show turbidity. That means at room temperature, 1 degree alcohol does not react with Lucas reagent. 2 degree alcohol, if you have alcohol, 2 degree alcohol plus Lucas reagent. Now, as you know, 2 degree will be a bit faster. That is why it shows turbidity at room temperature, turbidity, but it shows after 5 to 10. It needs time. The first 1 degree, it requires what? It requires heating. 2 degree requires time. 3 degree does not require anything. 3 degree alcohol plus Lucas reagent gives turbidity immediately. It gives turbidity immediately. Or if you got this, yes or no, please tell me. Or if you understood this now, yes or no? Aliza, Deborah, Father,
Yes, sir.
Sia, Hussain.
Yes, sir.
Now, the next one is mechanism. That is quite important. All of you wrote this down. If anyone is still writing, please let me. Okay. So write mechanism. First of all, if you have 1 degree alcohol, 1 degree alcohols that react with HX via SN2 mechanism. Okay, via SN2 mechanism. Those who don't know SN2, please don't worry. The first step is when you have a cleavage of HX. And so HX is going to break into H positive and X negative. H positive and you will get X negative. Okay. Now, in the second part, what is going to happen? You have R and OH like this. This is 1 degree alcohol, as I hope you can see that. This is alpha carbon connected to only one carbon atom. Oxygen atom, it has lone pair electrons. These lone pair electrons, which are electron rich, hydrogen H positive is what it is electron deficient. It is what it is electron deficient. That is why this is going to attack here, and we will protonate the alcohol. So I will have R bonded to oxygen atom. This oxygen atom is bonded to hydrogen as well as another hydrogen atom like this. And here you have a positive charge right now because it gave an electron pair. It gave an electron pair. Now, in the third step, what is going to happen? We'll have the X negative from the first step, and it will come and it will attack on the protonated alcohol. Protonated alcohol has one hydrogen here, other hydrogen is here, and a positive charge. Now, when this X negative attacks, it attacks on the alpha carbon, but there should be a question. This one should attack here because negative and positive will attract each other. Can you guys see this logically happening? Yes or no, please tell me. X negative is attacking oxygen atom. Yes or no, please tell me. Because oxygen is positive, X is negative.
Yes, sir.
Yes, but actually this reaction cannot take place. Why? I am telling you now. Now, look at the second step. Please don't write anything. Leave your pen aside and listen very carefully. Here, the oxygen atom has two lone pair electrons. One lone pair is attacking on hydrogen atom and making the bond. But this lone pair, it is still present on oxygen atom. Okay, the second lone pair is not gone anywhere. Now let us look at the oxygen atom. Oxygen atom with 3 bonds. No matter what the bonds are, there is a positive charge on oxygen atom for sure, but there is also a lone pair here. Okay, now each and every bond is made up of 2 electrons. Each and every bond is made up of 2 electrons. So it is having 2 plus 2, 4 plus 2, 6, 7 and 8 electrons. So in total, the oxygen atom, it is having how many electrons? It is having 8 electrons. That means it is having a complete octet. All of you know these words. Yes or no? Please tell me. Fadil, Fia, Aliza, Hussain and Majid. Octet, 8 electron. So it will be stable, right? Yes or no? Achha, one request to all of you guys. If you are using a space bar to speak, to turn the mic on, please don't do that. Okay, because I just hear noise if you turn on the space bar and speak. I don't hear any word. Okay, so if it is having a complete octet and oxygen, it cannot have more than 8 electrons, because oxygen, it is only having second shell. Second shell have a maximum of 8 electrons, and it is already having a maximum of 8 electrons. That is why these electrons, the X negative electron, it cannot attack on the oxygen atom. This attack won't happen. Rather, what is going to happen? This X negative is going to attack on this carbon atom, the alpha carbon atom. Okay, this carbon atom, which is what? Which is delta positive, because it is attached with oxygen, which is having positive charge. Electronegative oxygen atom is pulling electrons from the carbon. Now, when this happens, as soon as this X negative attacks on the oxygen atom, the bond breaks and the electrons move to oxygen to neutralize it, and we get R, this carbon atom as it is, and an X atom in place of O, plus you will get water molecule. All of you understood the reaction? Yes or no? Tell me the mechanism. Tell me, guys, all of you understood the 3 steps for mechanism? Did you understand the 3 steps? Yes or no? Please tell me.
Yes, sir.
Yes. Let me know. Okay. Is there anyone who is still writing this?
Yes, sir.
Anyone?
One second. Please let me know once you're done writing. Done, sir.
Right, next. Two-degree alcohols react with HX via SN1, and hence they can give rearranged products. What is the meaning of the statement? I will tell you right now. There is a reaction in NCERT textbook, the last reaction of alcohol chapter, in which you have 4 carbon atoms like this. Okay, this carbon atom, it is having a CS3 group. This carbon atom here, it is having a CS3 group. This carbon atom here, it is having OH. It reacts with HBr. So our expected product is the CS3, everything as it is. In place of OH, we should be getting Br. This is my expected product. But the actual product that we get is the 4 carbon atom are like this. This carbon atom gets the one having CS3. It gets the Br, and the CS3 is also here. Okay, the complete system has changed right now. So this is the actual product that we get. Okay, so this is the expected product, and this is the actual product. Okay, so you are going to write this product. This is the important product. Okay, so this is what it is formed. So how it is formed, we'll understand this in the mechanism. So please see. Now, first of all, I will write this reagent. Don't write anything now. Please see. I have CH3 here. And here I have OH. Obviously, in the presence of HBr, we will be having a lot of H plus. We will having a lot of H plus, right? We have the H plus here like this. Oxygen atom, it has lone pair electrons. It will attack on the H plus as we have done previously also. So 1, 2, 3, 4 carbon atoms. The CH3 is here. The CH3 is here. And here we have oxygen with 2 hydrogens and a positive charge. Now, because it is this carbon atom that we see, the alpha carbon atom here, it is a 2-degree carbon. So it allows the oxygen atom to leave with the electron pair and saying that I am very stable. I will be easily making a carbocation. So we will get again the same 4 carbon atoms. Same 4 carbon atoms. And the same 4 carbon atoms. And here we have the CH3 as it is. And here we have a positive charge, the carbocation, because as you can see, electrons are leaving the carbon. We have a positive charge. Okay. Now here the main story happens. Okay. Guys, tell me how many hydrogens are this on this particular carbon atom, the red carbon atom, in the chat, please. How many hydrogens in the red carbon atom? How many hydrogens in the red carbon atom, guys, in the chat? Please message to Salim, Aliza, Deborah, Fadil, Fia, Hussain, Majid. How many hydrogens in the red carbon atom? How many hydrogens in the red carbon atom? Hussain, try once more. Fia, correct. Hussain, please see once again. Aliza, correct. Very good. Deborah, no. Try once again. No. Fadil, no. Not right. See. This particular red carbon atom, it is making how many bonds? 1 bond, 2 bond, and 3 bonds, right? The maximum number of bonds in a carbon atom can be 4. So the number of hydrogen, it is equal to 4 minus bonds. So number of bond is 4 minus, 4 minus number of bond is 3. That will be equal to 1. So, okay. So this particular carbon atom, the red carbon atom, it is having how many hydrogens? It is having only 1 hydrogen. Having only 1 hydrogen here. Okay, I hope there is no doubt. Yes or no? Please tell me.
So,
No doubt, na? Okay. But please see very carefully what is happening. There will be electron density here. Correct? Bond means there is the presence of electron. Yes or no? Aliza, I need yes sir, no sir. Immediately, otherwise you will lose the track. And I will have to explain once again. Then you will again lose the track. There will be electron density wherever there is a bond. Yes or no? Pia, Hussain, Fadil, Deborah, and Aliza. Aliza, Deborah, you can't hear me. Aliza and Deborah, you can't hear me. I'm only
Yes,
teaching
sir.
Fadil here.
Yes.
What did I ask? What did I ask? Wherever there is a bond, there will be electrons. Correct? Yes or no? Fadil, Hussain.
yes, sir.
Hussain, what do you think? Wherever there is bond, there will be electron. Yes or no? Aliza, Deborah.
Yes, sir.
Okay. And since here we are having a positive charge, these electrons would be attracted to this positive charge because they are in the vicinity. They are neighbors here. This will be attracted towards this positive charge. So momentarily speaking momentarily means what? For a very minute time, for 1 second even, what can happen that this hydrogen can go towards this carbocation, this carbon having positive charge. So I will get something like this. This CH3 as it is. And if the hydrogen shifts there, the hydrogen will be here. And the red carbon atom will become a positive charge. It will get a positive charge. Correct, guys? Yes or no? Please tell me. For 1 second, can we assume that this is going to happen for 1 second because there is electron density? Electrons are also having wave nature. So for some time, momentarily speaking, the bond with carbon and hydrogen, it shifts to the positive charge. Yes or no? Please tell me. For 1 second, it can happen.
Sir.
Aliza, right? Okay. Now, once we have the positive charge on this particular carbon atom, the red carbon atom which was before, please see that this carbon atom, it is 2 degree. This carbocation, it is 2 degree. This carbocation, it is 3 degree. Okay. And if we have more alkyl groups attached, then here only we were having 2 plus I groups. Okay. So these were the groups which were giving electron. Now I am having 3 groups which are giving electron. Now we have more, if we have more positive charge, then it will be unstable. And if I add electron donating group, please listen to this very carefully. Those who have not done general organic chemistry with me, those who have done, यहाँ पे हम ऐसे बोल के चले जाते, 2 degree है तो कम stable, 3 degree है तो ज़्यादा stable है ना. But why it is happening? Please listen very carefully. Positive charge, charge means instability. Charge means instability. Charge means instability. So we have to lower the charge to make it stable. Right now we have a positive charge. So we need negative charges. We need a flow of negative charge towards the positive charge to make it stable. Positive charge is unstable. So we will put some negative charge to make it more and more stable. That is why if you give more electron donating group, electrons will be donated on that carbon atom, making the positive charge low. And as the positive charge lowers, the stability will increase. So 3 degree, this is more stable. This is less stable. Now, as we are in a more stable state, for 1 second, है ना? What happened? The hydrogen was said, 1 minute में आ रहा, 1 minute. But as soon as it got converted into 3 degree and it became more stable, will it go back to the previous unstable state? Yes or no? Tell me. क्या वो जाना पसंद करेगा? Will it try to go to the 2 degree once again, or it will, or it's going to stay in the 3 degree? That is the more stable state. What do you guys think? Tell me. Logically speak. Okay, speak logically. What do you think? If right now it is in more stable state, will it want to go to the less stable state? Aliza, Deborah, Fadil, Fia. What do you guys think? Will it go back to less stable state? Hanji, बताएं. What do you guys think? No answers, huh?
No, sir.
Aliza, Deborah, what do you think? Will it go back? Sorry?
No, sir.
No, right? Fadil, Majid, and Hussein. I hope you also understand that
Yes, sir.
we are already
It
in the
won't
more
go back.
stable state. It won't go back, no? Right?
Yes, sir.
Okay. So right now we have this particular carbocation, which is having a positive charge on this particular atom. And after that, the X negative will come. It will attack on this carbon atom, and we will get the actual product that we expected. The CS3 is, I mean, you can even write the Br here, same thing. I can write the Br here and the CS3 here, no problem. Correct. And I'm not showing hydrogen because hydrogens are generally not shown. And it is explicit. I showed hydrogen here because the movement of hydrogen was happening. But all of you understood this reaction mechanism? Yes or no? Please tell me. Anji, bataएं. All of you understood this? Yes or no? Now, this particular area, this here, this is known as 1,2 hydrogen shift. 1,2 hydride shift. 1,2 hydride, or rather, you just write hydride shift. Okay, so this step is known as what? Hydride shift. Hydrogen is shifting. Okay, please write this down. If you have not written, let me know once you're done. हुसैन, आपको समझ में आ रहा है? Yes, हुसैन, tell me. हुसैन की पहली क्लास है ना, पहली क्लास में रीअरेंजमेंट पढ़ लिया हुसैन ने. हुसैन, am I audible?
Yes sir,
हुसैन,
थोड़ा थोड़ा आ रहा है.
थोड़ा थोड़ा आ रहा है?
Yes sir.
ठीक है, और मतलब इतना समझ में आ रहा है ना कि इलेक्ट्रॉन्स जो हैं कहाँ से कहाँ फ्लो करते हैं,
Yes sir.
जहाँ पे इलेक्ट्रॉन रिच है और इलेक्ट्रॉन क्या होते हैं, स्पीसीज होते हैं ना, तो इलेक्ट्रॉन रिच से इलेक्ट्रॉन पुअर की तरफ जाते हैं. इतना समझ में आ रहा है कम से कम,
जी सर.
है
Yes.
ना, जैसे है ना, इतना समझ में आ रहा है, ठीक है. तब ऑर्गेनिक केमिस्ट्री आप समझ रहे हैं. एज वी कैन सी हियर, ऑक्सीजन लोन पेयर इलेक्ट्रॉन्स, मोर इलेक्ट्रॉन टुवर्ड्स H पॉजिटिव, लेस इलेक्ट्रॉन, इलेक्ट्रॉन रिच टू इलेक्ट्रॉन पुअर. अगेन बॉन्ड में इलेक्ट्रॉन होते हैं, वहां से पॉजिटिव चार्ज, इलेक्ट्रॉन रिच टू इलेक्ट्रॉन पुअर. अगेन द ब्लू, हियर वी हैव बॉन्ड, that means there is more electron, so electron rich से electron poor. X negative, negative means electron rich से electron poor. Okay, so basically complete organic chemistry is this only. Okay, electron rich to electron poor. I mean, at least the mechanism part and the reactions part is this only, electron rich to electron poor. ये वाला समझ में आया आपको? 3 डिग्री मोर स्टेबल, 2 डिग्री लेस स्टेबल.
Yes sir.
ठीक है, चलो, तो आप कुछ समझ गए फिर तो आप. Even though this question is there in NCERT, but it is not this hydride shift. It is not mentioned anywhere in the text. Okay, so you have the book, right? So in the book there are two parts. You have questions and then you have the text. So main content. So content में कहीं पे भी hydride shift नहीं है. Okay, rearrangement of carbocations नहीं है. Okay, that is why CBSE has never asked a question from this topic. आज तक तो हमें देखने को नहीं. Okay, but what now can happen? Now they may give you, I hope all of you know that there will be 2 case-based questions, right? So maybe in the case-based question, they can tell you about rearrangements. When we have carbocation, then rearrangement can happen. And then they can ask this question, you know, so that they will say, see, they can text to diya hota, they can argue also that we have already given the text as for the rearrangement of carbocation. That is why all of these questions, they become important. Okay. All of you done? Yes or no, please tell me. Is everyone done?
Yes, sir.
Yes, sir.
See, next we have 2 more reactions of alcohol. Okay. Now both of those reactions, they are already done in haloalkene halorine chapter. Fine. Now those who have not done haloalkene halorine from me, they have to watch the lectures. And I would suggest tomorrow is a holiday. You won't have any classes either in the school. Do you have school tomorrow? क्या scene है उधर? Do you have
No,
school
sir.
tomorrow?
Summer vacation.
No, no. Tomorrow
No.
is a holiday.
Yeah.
So tomorrow you will get time. At least watch first 2 or 3 lectures of haloalkene halorine. The first lecture is very easy. It is just the classification of haloalkene halorine. There is no reactions. And then watch the second lecture. In second lecture only, you will see 2 reactions. The reaction of alcohol with reaction with phosphorus halides, I will say phosphorus halide or for phosphorus based reagents. It would be of some of that name. And there will be a second reaction that you have to write. And I mean, in the text, it will be third reaction, never order, right? So because this is the first reaction that we are learning, right? In reactions involving cleavage of COH bond. The next reaction that you have to write is reaction with ionyl chloride. These are very basic reactions, and both of them you are going to get in the method of preparation of haloalkene. And this is a very common theme in organic chemistry, that the reactions are going to be repeated. Okay, the reactions are going to be repeated. If you are having a reaction right now in the alcohol chapter, so it will be also there in aldehyde chapter for sure. Okay. All of you understood what to do? Yes or no? Please tell me. Those who have done haloalkane with me, please you can flip some pages and check whether these reactions are there in your notebook or not. Okay, so basically Fia and Deborah, I think both of you have done haloalkane with me.
Yes, sir, it's there.
It's there now. So you guys are going to write. I think if you leave half a page, it will be enough, right, Fia? Half page will be enough, or one page?
Yes, sir, it's less only.
It's less only, no? So leave half page and then write the fourth reaction that we are going to do. Write the fourth reaction, acidic dehydration. Acidic dehydration. Now what happens here, please? You should have a carbon atom with OH, alcohol, and there should be a beta carbon with at least one hydrogen. Beta carbon should be having at least one hydrogen, right? So carbon with OH, that will be obviously what? That will be the alpha carbon. And here you have a beta carbon which is having hydrogen. In the presence of acid, in the presence of what? In the presence of acid. That means H plus. And some heat, this water molecule is broken away. HOH is broken away. Okay. And we get a double bond between the carbon atoms. So we have the beta carbon and alpha carbon, they get a double bond. Now what is happening here? Please see. This carbon, the alpha carbon, what carbon? The alpha carbon, OH bond, and the beta carbons, CH bond, both of these are breaking. And carbon-carbon double bond is getting formed. Correct, guys? So alpha and this is beta. And this is beta and alpha, carbon-carbon bond is formed. Right? Yes or no? There is nothing else happening. Okay, there is nothing else happening. So whatever group is attached on the beta carbon and the alpha carbon, they will be remaining as it is. They won't be changing. They will be as it is. Okay, so right here, alcohols with at least one beta hydrogen, at least one beta hydrogen reacts with protic acid, for example, H2SO4 or H3PO4, etc. Basically, you will be using H2SO4. Right? Even if you have H+, that's the same. To form alkene via beta elimination. So what does it mean? It means OH is removed from alpha carbon and hydrogen is removed from beta carbon. Hydrogen is removed from beta carbon. All of you understood this? Yes or no? Please tell me.
So,
Write a note. Please write. Alkene is formed by, rather, alkene is formed via Set-Zef rule. Alkene is formed via Set-Zef rule. What is the Set-Zef rule? One of the statement of Set-Zef rule you can write as, please write, see here. Hydrogen is removed from that beta carbon which has less number of hydrogen. Which has less number of hydrogen. All of you understood this? Yes or no? Please tell me.
yes, sir.
Okay, so the counting of hydrogen is very important. Okay, the counting of hydrogen is very important. For example, I have something like
Also, the more substituted alkene will be the major product.
you can write that also. Okay, so I will explain it after I have formed the alkene. Okay, the same thing. So you have OH, right? Now you have 1, 2, 3, and 4. Which is the alpha carbon here, guys? Which is the alpha carbon here? 1, 2, 3, 4. Which is the alpha carbon? Identify the alpha carbon. बोलो ना यार, ये ऐसे शांत क्यों बैठे हो यार तुम लोग? हाँ, हम क्लास बंद कर देंगे इस तरह से रहा है आप लोग तो. अलीजा, डेबोरा, keep your mic on, all of you guys. All of you,
Second
please
carbon,
keep your mic on, all of you.
Yes,
गुस्सा
sir.
दिलाने के बाद, अलीजा, keep your mic on. Deborah, keep your mic on. Hussain and Majid, keep your mic on. Hussain, you're not present in the class. Okay, Hussain is not here. Hussain is there. Yeah.
Yes.
Keep your mic on. Which is the alpha carbon? 1, 2, 3, 4. Mein?
Second, sir.
Okay, all of you can identify it as the second carbon atom, which is the alpha. Very good.
Yes,
What
sir.
about others? बाकी लोग बताएं alpha carbon. Fine. All of you will tell me what are the beta carbon here. What is the beta carbon? What is the
1
beta
and
carbon?
1 and
बाकी
3.
लोग 1 and 3.
1 and 3.
This is your very good. This is the beta carbon and this is the beta carbon. Hai na? So we don't need to worry about the fourth carbon atom. Fine. Now tell me the number of hydrogens in 1 and 3. How many hydrogen in the first carbon atom?
Sir, 3.
What about others? Tell me. How many hydrogens in the first carbon?
3
Hussain,
carbon.
Majid. Okay. Now Majid will answer. Okay, no one else will answer. Majid is not answering. First carbon में 3 hydrogen. Very good. What about the second one? Sorry, third one. Majid will answer. Majid, how many hydrogens in the third carbon? Majid, how many hydrogens in the third carbon?
2.
Majid, I am asking you. You have to either say the answer or say I don't know. If you won't speak, it's not going to help. जोर से बोलें, please.
I don't know, sir.
ठीक है. Can you tell how many bond? अच्छा. By the way, except Majid, can all of you turn your mic off?
Yes, sir.
Majid, keep your mic on.
हाँ.
जी. Can you tell me how many bonds are present in the third carbon? कितने bonds दिख रहे हैं third carbon में आपको?
3.
2 दिख रहे हैं, बिल्कुल. कोई इसमें परेशानी नहीं है ना आपको? तीसरे कार्बन में 2 दिख रहे हैं, है ना? अरे हाँ है ना, जल्दी बोले ना. So अरे फिर माइक ऑफ कर दिया. हाँ, माइक ऑन रखें. नंबर ऑफ हाइड्रोजन विल बी इक्वल टू 4 माइनस बॉन्ड्स. क्या है बताइए? नंबर ऑफ हाइड्रोजन इज इक्वल टू, बोलो भाई. अरे लिखा हुआ है यहाँ पे, बोलो भाई. आवाज ही नहीं आ रही है.
No.
ठीक से बोले जरा प्लीज. या Majid, tell me. Number of hydrogen is equal to
3. 2. 2.
Got it?
Yes.
Okay. In the second carbon, tell me how many hydrogens?
2.
In the second carbon,
Second carbon.
ये है ना सेकंड अल्फा जहां पे लिखा हमने रेड वाला. कितने बॉन्ड्स नजर आ रहे हैं उस कार्बन पे?
3.
हाउ मेनी? 3. तो कितने हाइड्रोजन्स हो जाएंगे?
2.
2. क्या बोल रहे हो यार?
3.
हाउ मेनी? अरे फॉर्मूला बोलो यार, क्या है? पता नहीं कहाँ ध्यान है आपका. फॉर्मूला बोलिए क्या है? व्हाट इज द
4
फॉर्मूला?
minus 1. 4 minus 1.
तो कितने बॉन्ड्स हैं? हाउ मेनी बॉन्ड्स?
1. 4 minus
सॉरी, हाउ मेनी बॉन्ड्स इन
4
द सेकंड कार्बन माजिद? हाउ मेनी बॉन्ड्स?
3 bonds. 3 bonds.
तो हाउ मेनी हाइड्रोजन्स?
1.
तो फिर ये इतना आसान चीज है, आपको इतना टाइम लग रहा है? ध्यान दीजिए प्लीज. If you have anything in front of you, if you have people around you, please go somewhere else and sit down quietly at a room. Okay? If you guys have any disturbance, then please don't be there. ऐसे लेट वेट के अगर आप लोग क्लास कर रहे हैं तो अल्लाह आपकी मदद करे. ठीक है? ध्यान से देखिए, ऑर्गेनिक केमिस्ट्री एक बार कोई चीज छूटी बस खत्म. वो तो मतलब ये मेरे पेशेंस है कि हम कब तक आपको समझाते रहे कि कितने हाइड्रोजन है. एक पर्टिकुलर छोटी सी चीज है, हम ज्यादा कितनी बार समझाएंगे इस चीज को? नंबर ऑफ हाइड्रोजन इज इक्वल टू 4 माइनस बॉन्ड. ठीक है? एंड सिमिलरली सेट्जेफ रूल, अगर आप लोग हैलोअल्किन हैलोरीन पढ़े होते तो हम ये बताते भी नहीं आपको ये सारी चीजें जो भी हम कर रहे हैं. ओके, आई वुड नॉट हैव इवन टॉट 1 हाइड्रोजन 2 हाइड्रोजन, ये इतना हो. तो सीधा सेट्जेफ रूल के बाद आपको प्रोडक्ट पता होना चाहिए क्या होगा, बिकॉज सेट्जेफ रूल इज देयर इन हैलोअल्किन हैलोरीन. ठीक है? So please, each and every class, each and every moment in the class, it is important. सवाल हर जगह से आए. Now, here we have 2 beta carbons, the green beta and the blue beta. किस बीटा से हाइड्रोजन निकलेगा? In the chat, please tell me. Or either you can see which beta we have 1 and 3 in the chat. In the chat. 3 से निकलेगा या 1 से निकलेगा? कहां से निकलेगा हाइड्रोजन? Yes, very good, Alisa. Hydrogen will be removed from which carbon? The first carbon or the third carbon? Yes, Hussain, very good. Others, please answer in the chat. Message to Salim. The answer is written in the note itself. Okay. Yes, Fadil, very good. Correct. Pia, I'm not getting your answer. Pia here. Pia, send your answer now. I hope you should be able. Now we have already done this in haloalkane haloene. The reaction with alcoholic KOH of haloalkane. More substituted बोल रही थी ना. तो कौन से? I'm asking which carbon the hydrogen will be removed from which carbon atom? Hydrogen will be removed from which carbon atom? 1 or 3? Yeah, very good. ठीक है, फाइन. हुसैन ने आंसर दे दिया. मतलब इतना तो है कि जो पहली क्लास कर रहा है उसको भी आंसर पता है. ठीक है? So please see, if I react this with H2SO4, okay, and in the presence of some heat, we have having how many carbons? 4 carbon atoms. So you'll make 4 carbon atom as it is. Okay. After that, from the second carbon atom, OH will be removed. From the third carbon atom, hydrogen will be removed. Third carbon atom, hydrogen will be removed. That is why a double bond will be formed between alpha and beta. Which beta? The 2 hydrogen beta. All of you understood this product? Yes or no? Please tell me. This
Yes,
will be the major product. This will be the major product. You will get a minor product. We don't write those minor products generally. In the question also, you will be asked write the major product for the following. So the minor product will be, you are removing hydrogen from the first carbon atom. This will be minor product. Okay. Now, one statement of the Setzef rule, it is something like this. It says that more substituted alkene is major product. What is the meaning here? Please see very carefully. When we talk about alkene, then you have to focus on this carbon atom and this carbon. If I talk about this minor product, then in that case, you will be having CH2 here. So you have to focus on this carbon atom CH2 and this carbon atom here. Okay, this carbon atom here. Now, alkene is obviously the double bond. It is made by 2 carbon atoms. Now, look at both the carbon atoms. Okay, so here we have 1 carbon, 2 carbon. Okay, here also we have 1 carbon and 2 carbon. In the major product, 1 carbon has an alkyl group, 2 carbon also has an alkyl group. So in this